Okay, welcome back. We're going to be talking about solving quadratics by graphing. We are going to also talk a little bit about how to solve when a quadratic is in a system of equations. So the first thing we need to talk about is a new vocabulary word, which is the zero of a function, and we talked a little bit about that when we did the key features of functions. The important thing to understand is that roots or zeros or solutions of equations all mean the same thing, and that is they occur wherever the graph of a function intersects the x-axis. So where f of x equals 0 or where y equals 0. So we will call these roots or zeros or solutions. So if anybody asks you to solve an equation or find the roots or find the zeros, what they're asking you to do is to make this value of y equal to 0 and then solve for x. So x squared minus 4 equals 0, which means x squared equals 4. And when you take the square root of something that has been squared, you need to consider that it could have been positive or negative. So x equals positive or negative 2. And we can graphically see that that's true by looking at the x-intercepts on the graph here. Okay, so if I give you a related graph and an equation, you can go ahead and take a look at the graph, and we see that our x-intercept is right here. So our solution should be x equals negative 3, and we can double check that that works algebraically by throwing that into the equation. So negative 3 squared minus 6 times negative 3 minus 9 should be equal to 0. That is negative 9 plus 18 minus 9 should be equal to 0, and indeed that is true, so that we know x equals negative 3. Now, sometimes we will have to solve the equation, and since this is something that you can put into your graphing calculator or double check for the x values, I'm going to start you off and then go ahead and ask you to calculate the y's on your own. So to calculate the axis of symmetry, x equals negative b over 2a. So negative of negative 6 is positive 6 over 2 times negative 2 is negative 4. So negative 1.5 is our axis of symmetry, and so we can graph negative 1.5 right here. And we're going to go ahead and put that in. So if we put in negative 1.5 for x, we want to find some y's. So then I'm going to go ahead and ask you to put in some more y values, and you can go ahead and pick some more if you want, but I'm just counting integers on either direction. So we're going to go ahead and do that. Go ahead and pause the video right now, calculate some x values, and we'll come back and talk about their corresponding y's. Okay, when x equals negative 1.5, y equals 9.5, and so we can graph that right here. And when x equals negative 1, y equals 9, y equals 9, and that also goes for negative 2. So we can graph right here. When x equals 0, y equals 5, and we can reflect that across. So when x equals negative 3, y equals 5. And when x equals 1, y equals negative 3, and we can reflect that across to negative 4. And so we can graph 1, negative 3, and 4, negative 3, and very carefully graph this quadratic function as accurately as we possibly can with as rounded a base as possible. And we notice that the solution to our equation isn't a nice integer. And so we can just write the solution. So the solution to this equation are between 0 and 1 and negative 3 and negative 4. Okay. let's try graphing this one. So if we want to always start with the axis of symmetry, we're going to start with negative b over 2a, so negative 5 over 2 times negative 1 is negative 2, so that's 2.5. So if we graph the axis of symmetry at 2.5 here, I'm going to pick some additional x values, so I'm going to also want to graph 2 and 3 and 1 and 4 and probably 5 and 0. Okay, so go ahead and pause the video right now, get some y values that relate to those x values. Okay, so when we put in 2.5 for x, we get out negative 1.75. And so we graph the vertex here at 2.5, negative 1.75. So that's approximately here. And we should notice right away that our A is negative, but our vertex is below the x-axis. So that might cause a problem. And in fact, once we find the value for 2 and 3, we notice that those y values are both negative 2. So this graph is certainly going down. So 2, negative 2, and 3, negative 2. Oops. 2, negative 2, and 3, negative 2. So this quadratic is going to always go down and never cross the y or x-axis. So there are no real solutions. We don't say there are no solutions because there are. They're just not real solutions. Okay, last problem. We're going to go ahead and graph a linear and a quadratic together. So the linear equation, we start off with y equals 2, and we're going to go up 1, down 1, and try to graph a straight line to the best of our ability. So we can go ahead and mark out some points so that we can follow them all the way up and down and try to keep our linear function as straight as possible. At home, I strongly encourage you to use a straight edge. That doesn't come across real well in the picture, so I apologize here. Then we're going to go ahead and graph our quadratic, which we use negative b over 2a to get our axis of symmetry, so negative 6 over 2 times a, so divided by 2 is negative 3. So our first x value is going to be negative 3, and when we put that into our function, we get negative 3 out. So we're going to go ahead and graph the axis of symmetry at negative 3. And we're going to graph our function at negative 3, negative 3, right here. And then I'm going to pick some more x values. So I'm going to go ahead and pick negative 2 and negative 4 and negative 1 and negative 5 and 0 and probably negative 6 also. So when I put in, go ahead and pause the video and find some corresponding y values. Okay, so negative 2, negative 2, negative 4, negative 2. So I graph those. And then when I put in negative 1, I get out 1, and reflecting that, I also get out 1 here. So 1, 1, and negative 5, 1. And when I calculate the 0, I get 6, and negative 6, I also get 6. So 0, 6, and negative 6, 6. And then I can go ahead and connect those quadratics. And the solution to my system of equations is going to occur when the two graphs intersect. And had I graphed that accurately, you would see that they intersect in two places. One is right here, and the other is right here. And so we are assuming that our solutions are negative 1, 1, and down here is negative 4, negative 2. Negative 1, 1, and negative 4, negative 2. So we want to just check and make sure that that works for both equations. So we already know that that works for the quadratic because we use that. So we can double check the linear function to make sure that works. So if I check -4, -2 in for y equals x plus 2, so -2 should equal -4 plus 2, and in fact -2 does equal -2, so that works. And I also want to check -1, 1, so 1 should equal -1 plus 2, and in fact that does. 1 equals 1, so that checks out. So -1, 1 and -4, 2 are solutions to this system of equations. Okay, if you have some questions, go ahead and watch some more examples video. Otherwise, go ahead and complete the 2-4 solving quadratics by graphing reflection. After that, go ahead and watch the solving quadratics by factoring video. Thank you so much for listening.